You ever see this happen? You're in a patient's chart in Epic, and suddenly there's this piece of data from some third-party app. It's just there. And you think, wait a minute, how did that get there? Well, it's not magic, even though it kind of feels like it. It's actually a really cool data journey. So let's pull back the curtain and follow one of these little pieces of data on its amazing round trip.
Yeah, this is the big one, right? I mean, pulling data out of a system, we've been doing that for a while. But writing data back in, that's a whole different ballgame. It's kind of like the holy grail of interoperability. And today, we're going to break it all down and take away all the mystery.
So the best way to think about this is like a story. It's a four-step journey, a complete round trip for our data. It leaves home, that's Epic. It goes out into the world, gets a little smarter, and then it comes right back to do its job. When you see it as a loop, the whole thing just clicks.
All right, let's kick things off with a real-world problem. Picture this. A cardiologist is with a heart failure patient. What they really need to know is the patient's 30-day readmission risk. Super important, right? But here's the catch. That score doesn't exist in Epic. The calculation needs data that Epic just doesn't have. Now, there's this cool third-party app. We'll just call them Predict Health for our example. And they can create that score. The big question is, how do we get that crucial piece of information out of their system and into the doctor's hands, right inside their workflow?
Okay, step one is all about getting through the front door. We're calling this the digital handshake. But think about it. There's no person here to type in a username and password. This is a machine talking to another machine. So it needs a totally different kind of key, a really secure, automated way to say, hey, it's me. You can trust me. So let's compare how this works. We all know the human login, right? A doctor logs into hyperspace with a username and password. Easy. But for a service, it's different. Our Predict Health app uses something called a private key to create this unique digital signature. The technical term for it is a JWT, which stands for JSON Web Token. You can just think of it like a super secret, unforgeable password that proves the app is who it says it is. The whole process is basically like a digital bouncer at a club. First, Predict Health shows its ID. That's the signed JWT. Your interconnect server, which is the bouncer, looks at the ID, checks the signature, and says, okay, you're on the list, you're legit. Then, instead of letting it roam free, Interconnect gives it a temporary wristband, or what we call an access token. This is like a digital visitor's badge. It's only good for a short time and only lets the app go to certain places to do a very specific job.
All right, step 2, the data pull. So our app is in the door. Now it needs to get the raw materials for its recipe. In this case, some specific clinical data from the patient's chart. But remember that visitor's badge? The app can't just wander around. It has to ask very politely for exactly what it needs, and it has to ask in a universal language that everyone can understand.
And this is what that ask actually looks like. It's a FHIR API call. FHIR, that's FHIR, stands for Fast Healthcare Interoperability Resources. It's the modern language of healthcare data. Now look closely. It's not asking for something vague like the BNP lab result. No way. It's asking for a very specific observation linked to a universal code from Loink, and that's the key. Using a standard code like Loink means this app isn't just custom built for your Epic system. It can talk to any hospital system that speaks FHIR.
Now, for any Epic analyst watching, this is where it gets really interesting. The app is out here speaking the universal language of FHIR. But inside Epic, the data doesn't live like that. Oh no, it's deep down in Chronicles, Epic's huge database in its own very specific proprietary format. Think res records, EPT records, you know the drill. The point is, the two systems don't speak the same language. At all.
And this is where Interconnect becomes our hero. It's the universal translator, just like in Star Trek. It dives deep into Chronicles, grabs that internal data, and then, poof, it translates it into this beautiful, clean, universal JSON format. JSON is the language of the web. Pretty much any modern app can understand it. So, just like that, our data is packaged up and ready to leave the building.
Okay, step 3, the outside insight. Our little piece of data has now safely traveled to the Predict Health cloud, and this is the part where the real alchemy happens. This is where our data from Epic gets combined with brand new information, stuff Epic never knew about, to create something completely new and powerful. So how do they do it? Well, Predict Health takes that clinical data we pulled from Epic, like the patient's BNP lab value. Then they mix it with their own secret sauce. This could be external data, like social data based on where the patient lives. Finally, they feed all of that into their own smart AI model. This is the value add. This is why we went through all this trouble in the first place. And what comes out the other end? A single powerful number, 92. That's it. That's our brand new readmission risk score. It's a piece of intelligence that was impossible to create using just the data inside Epic. But it's not useful yet. Right now, it's just sitting on Predict Health's server. We've got to get it back home.
And that brings us to step 4, the write back. This is the final leg of the journey. And honestly, this is the part that feels like magic to most people. The app, still holding that temporary access token, is now going to send that score all the way back into Epic and file it perfectly in the patient's chart.
But hang on, here is the million-dollar question, especially for any Epic builders watching. How does the app know exactly where to put this score? You can't just tell it, hey, put it in the vitals flowsheet. Why? Because the internal record IDs for that flowsheet are different in your test environment, your training environment, and your production environment. So how in the world do you create a link that never ever breaks?
The answer, and this is so important, is something called an OID. That stands for Object Identifier. Think of it this way. A regular Epic record ID is like telling someone your cubicle number at work. If the company reorganizes the office, that number is useless. But an OID is like your permanent home address. It doesn't matter what happens at the office. Mail sent to your home address will always find you. You, the Epic analyst, set up this permanent address for, say, a specific flowsheet row, and it stays the same everywhere, forever.
So that's the absolute key. The OID acts as that permanent mailing address that you give to the vendor. They just send the data, that score of 92, to that address. Interconnect sees the address and knows exactly which internal filing cabinet, which specific flow sheet row to put it in. This is what makes the whole write-back process so solid and reliable.
And just like that, the loop is complete. We've reached the payoff. Our little piece of data has made its full round trip. It came back home, but it's not the same as when it left. It's smarter, it's more valuable, and now it's ready to actually help improve patient care.
And this is what it's all for. The cardiologist opens the patient's chart and bam, there it is. Readmission risk score 92. It's sitting right there in their flow sheet, looking like any other piece of data. It feels completely native, as if a nurse had just walked in and typed it in themselves. The entire complicated journey we just followed, it's completely invisible to the doctor. It just works.
So let's do a super quick recap of that full data loop. Step 1, authenticate. The app uses its secret key to get a temporary badge. Step 2, pull. The app asks for data and Interconnect translates it from Epic speak to a universal language. Step 3, synthesize. The app works its magic and calculates the new score. And step 4, write back. It sends that score home to a permanent address, the OID. 4 steps. That's the whole shebang. Simple, powerful, and honestly, a total game changer. So, we've just tracked the journey of one single score. But now that you know how the loop works, just think about the possibilities. What's the next piece of outside intelligence that could change patient care? What's the next data loop that you could build to make the chart and the care we provide that much smarter?